Okay, in this video, we will take a look at this exponents assignment. This is an Algebra 1 assignment. In Texas, the learning standards are 11B, which is a STAAR readiness standard, and then one of the questions actually includes a secondary learning standard of 12B. We'll see how 12B mingles into the 11B mix, but the 11B TEAC is about simplifying exponential expressions using the various exponent rules. So in this assignment, the students are tasked with applying the product rule and the quotient rule. And those are the only two rules needed before a student can complete this assignment. Like I said, for the last couple of questions where 12B comes into play, there is a little bit more complexity, but these are fairly straightforward problems. And we'll start with number 1. What is 3 times 4 cubed, or 4 raised to the third power? As we apply these exponent rules, this first problem here is more of a check to make sure that the student understands that even though a lot of the manipulations involve variables, we can't forget how to square, cube, and raise to various powers, just regular numbers. So the way this works for number 1 is we have 3 times 4 raised to the third power. Now, as we've told the students, 3 is not really 3, it's 3 raised to the first power. The problem is we can't do any of our product rule tricks with this particular expression because 3 and 4 represent different bases. So in this case, we have to use order of operations, cube the 4, and then multiply it by 3. So what this looks like is 3 times 4 times 4 times 4. So however you want to take it, you can multiply this out, but it comes out to 3 times 64. And 3 times 64, if we do it the old-fashioned way, is 192. So the correct answer is A, 192. Okay, on to number 2. What is 4x cubed times 2x cubed? All right, so let's write this out. 4x cubed times 2x cubed. So when you have coefficients next to variables of the same base, in this case the base is x, you multiply the coefficients, okay? Then you put the base and then you add the exponents. So in this case we have 4 times 2, which is 8. Okay, the base is x, and then we add the exponents, 3 plus 3. So this is 3 plus 3. 3 plus 3 is 6. So this expression is simplified to 8x to the 6th power. And that is option, answer choice A. All right, down to number 3. Which answer makes the product of x raised to the 5th power and x raised to the 3rd power true? This is a really confusing way of asking the question, but it does show up on the STAAR test, so we like to cover it, make sure students understand how to kind of unpack this language. The key word here is product, which indicates we're going to multiply x to the 5th times x to the 3rd. The same bases exist, so we can use the product rule and just add the exponents. So x to the 5th times x to the 3rd equals x to the 5 plus 3. Now this intermediate step is not entirely necessary, but just want to show it. That's how we get x raised to the 8th power. So looking at the answer choices, you can see that here on answer choice B, the test maker has assumed that the student might try to multiply the exponents, and that's a little crocodile there hiding in the water. You're adding the exponents using the product rule. This can be very confusing because we're talking about multiplication here, but the multiplication is occurring between the bases and not the exponents. So in this case, it's just x to the 8th, which is option A. On to number 4. What is 2x cubed times 2x squared? Okay, so 2x cubed times 2x squared. Well, this is just like problem 2. We have the same base, so we're going to multiply the coefficients. 2 times 2 is 4. Okay, then we write the base, which is x, and then we add the exponents, 3 plus 2. So 3 plus 2 is 5. All right, so I'll just continue the tradition here. 3 plus 2, which gives us 4x raised to the 5th power. So 4x raised to the 5th power is answer choice C. All right, we're just humming right along. Starting with number 5, we have to apply the quotient rule. The quotient rule is very similar to the product rule, but it applies to division of bases with exponents. In the first problem, we're again presented with a situation where we have a number instead of a variable, but because both the numerator and denominator bases are 6, we can actually write this using the quotient rule. The quotient rule here would be 6, right? That's the base, and then we subtract the exponents from one another. So we're going to say 6 raised to the 5 minus 3. 6 raised to the 5 minus 3. And 6 raised to the 5 minus 3, well, 5 minus 3 is 2. So we're given 6 raised to the 2nd power, also known as 6 squared. Okay, and if you need to compute that, it's just 6 times 6, and that equals 36. All right, so what we're looking for here is C on number 5. Due to a little printing error in an earlier edition of this assignment, students were presented with an identical question here, but number 6 was intended to be this question, so we'll solve this question here in this video. What is the quotient of x raised to the 5th times y raised to the 6th divided by x times y raised to the 2nd? I teach students to take this in parts. I say look at your x terms and look at your y terms individually. A lot of students will try to multiply the x's and the y's in the numerator and do something in the denominator and then attempt to divide. So it's good to just say, hey, take your x's and take your y's and just, take it one step at a time. So let's take the x base, and then this is where knowing that, say we call this like a naked variable or a variable all by itself, is actually raised to the 1st power. So that's really important to remember when we're looking at the denominator, because when we do our subtraction, when applying the quotient rule, we're going to take 5, and then we have to subtract something. We're going to subtract 1, because x is raised to the 1st power in the denominator. All right, then we'll take the y. Okay, so we'll write the base y. Okay, and these are going to be multiplied, although that's understood. Okay, now it's a little bit more straightforward because we have exponents given in the numerator and denominator. So this would be y raised to the 6 minus 2. Okay, so if we're going to further simplify this, we have x raised to the 4th power times y raised to the 4th power. And that is answer choice C. Number 7. Which of the choices below make the value of 6 times x raised to the 7th power divided by 2 times x raised to the 4th power true? Writing the expression out like this using the division symbol here instead of the fraction bar can be a little confusing to students. So the very first step is to actually rewrite this as a fraction, 6x to the 7th power over 2x to the 4th power. Just like in the product rule, when we apply the quotient rule, remember we can't forget how to just straight up divide numbers. So the first step here is to divide 6 by 2, and that divides evenly. So we get 6 divided by 2 equal to 3. And then we have to write the base of x and then 7 minus 4. Okay, so this ends up being 3x raised to the 3rd. So 3x cubed. And that is answer choice A. Number 8. What is 8 times x raised to the 5th power divided by 4 times x raised to the 2nd power? Again, we'll write it out. 8x raised to the 5th divided by 4x raised to the 2nd, okay, equals 8 divided by 4, which is 2. Okay, write the base of x and then perform your quotient rule subtraction. Subtract the exponents 5 minus 2. And this gives us 2 times x raised to the 3rd power. So 2x cubed is the answer, and that is answer choice A. Number 9. This is where the function notation comes in, and I think number 9 and number 10 should probably include this secondary standard 12BR, which asks the students to evaluate functions with given different x inputs. I'm kind of bending that here. I couldn't really find a TEK that captured what it was I was trying to have the students do here. But nevertheless, maybe there is a better TEK. But it says if f of x equals 4 times x raised to the 8th power and g of x equals 10 times x to the 9th power, what is g divided by f? All right, so first, the student needs to unpack this information. Say, what is being asked of me here? Well, what's being asked of you, student, is that you take this expression and divide it by this expression, because you're going to divide g by f. Okay, real common mistake here would be to divide f by g, but look what it says, divide g by f. So g divided by f, well, you can write it down here, g divided by f equals 10x raised to the 9th power divided by 4x raised to the 8th power. All right, so here we can't evenly divide, 4 into 10. So we have to simplify or reduce the fraction by finding a greatest common factor. So if we look at 10 and we look at 4, the greatest common factor between these two numbers is 2. So this is a little bit of a complicated skill for some students, I'm finding, but they need to recognize that given the greatest common factor of 2, what we're going to do is this little intermediate step of dividing 10 by 2 and leaving it in the numerator. Okay, so I'm going to actually write this out. Say 10 divided by 2 equals 5, and then 4 divided by 2 equals 2. right? So I kind of want to plug this here, and I'll bracket this off as a little, just so we understand what we're doing. So we now have the new expression 5 over 2, and then we write our base, x. Now we do our quotient rule subtraction, 9 minus 8. 9 minus 8 is 1, so to go down here and put equals, g divided by f equals 5 halves, or 5 over 2, x. You could say raised to the first power, but like we said, I'll write it here because students tend to write that 1, but conventionally we don't write the 1 as an exponent, so we just say equals 5 over 2x. All right, so if we're hunting for that, we find that in answer choice B. Okay, number 10. What is, and this is actually a printing mistake, this is actually supposed to say if. Okay, if f of x equals 8 times x raised to the 5th power divided by 4 times x raised to the 2nd power, and g of x equals 6 times x to the 7th power divided by 2 times x to the 4th power, then what is f divided by g? So this actually requires reciprocal multiplication because we're dividing a fraction by another fraction. So I'm going to stack this up and show you what we're doing here. So f divided by g really equals 8x to the 5th power divided by 4x to the 2nd power divided by 6x to the 7th power divided by 2x to the 4th power. So this looks like a mess, right? So we're going to use reciprocal multiplication and say, let's do this a different way. 8x to the 5th power over 4x to the 2nd power times the reciprocal of this expression for g of x. So the reciprocal there is times 2x to the 4th over 6x to the 7th. You might want to pause the video right there if that's confusing to you, because that was the key. You had to flip the numerator and denominator in g of x. Okay, now we're just going to multiply the numerator out. First, we have common bases, so this will work. 8 times 2 equals 16. And then we write our base of x. And then we have 5 and 4. 5 plus 4 is 9. So 16x over 9 over, let's multiply. We have the same base, so we'll multiply our coefficients. 4 times 6 is 24. Then x squared, okay, that's the 2nd power, and then x to the 7th power. We're going to add 2 and 7. So we'll write the base of x, and then we'll raise it to the 2 plus 7th power, which is 9. 2 plus 7 is 9. Now here's the key. We have 16 over 24. Okay, and then you have x raised to the 9th power and x raised to the 9th power. Anything divided by itself is 1. So as a matter of fact, we can actually cancel these out. And that's really the key in this problem. So we're going to rewrite this all equals 16 over 24. Now we have to simplify this fraction, finding a greatest common factor, which in this case is 8. So we'll divide both the top and the bottom by 8. 16 divided by 8 is 2 over 24 divided by 8 is 3. So this entire problem reduces down to 2/3, and that is answer choice B. Probably the most common other choice is D that the students come up with because they want to keep that X for some reason. So it's important to focus on the idea of canceling out the x raised to the ninth over x raised to the ninth by pointing out that, hey, however complicated you find this stuff, that is the same thing divided by itself, and whatever that is, blob over blob equals 1. So it's just 2/3. All right, that was the assignment, and this is a good little refresher or introductory lesson on applying the product and quotient rule to exponents, teaching the Readiness TEK 11B and the Readiness TEK 12B. Thank you very much.